Good afternoon, grade 7s. We're going to go over your 10.2 part 1 notes. So above you'll see on the first little bit here is just a review of the different terms that we're going to be seeing in this chapter and a review of the ones that you saw in 10.1. Let's just remember that a variable, is just a letter that represents an unknown number. We have been using the variable x or n, and today we'll be using the variable d. Remember that it's just a letter that holds the place of a number. It can change. Whereby the constant is a number that does not change. All right, you might see an add, in this case, add 6 or subtract 8. Those are constants and they will not change. The difference between an expression and an equation is that the equation has an equal sign. Okay. And numerical coefficient, remember, is that which multiplies the variable. So you might see a letter right beside, or a number right beside a letter, and what you can do to remember that is that they hold hands and they multiply. Okay. So you can pause right here and take a look at the different identifying the parts of the following equations or expressions. And all you're going to do is to identify what a variable is, what the constant is, or what the numerical coefficient is. So in this first example, you might say that the constant is add or positive 6. The variable, of course, remember, is the letter. And the numerical coefficient is that which multiplies that variable. Pause here and give those a try. We're going to go over the example 1 now that you find in your notes, and it's describing your pattern using the variable. So the question is a kitchen floor is being covered with red and white tiles. The basic design is shown. Several of these basic designs are fitted together to make a pattern. So in design 1 here, design 2 is 2 of those basic designs, and in design 3 there's 3 basics. First step, no matter what the situation, is to always make a table, and one has already been provided for you, so we're just going to continue making it. Okay? So in design 2, let's look. You can almost ignore the white tiles for right now. We're just going to look at the red tiles. So in design 2, how many red tiles were there? 1, 2, 3, 4. So we'll just add the number 4 there. In design 3, how many red tiles were there? Well, looks like they're going up by 2s. So therefore, be 2, 2, 4, 6. Okay. Separately, now let's look at the number of white tiles. In design 1, if you were to count, you would discover there were 10 white tiles. In design 2, there were 20. And in design 3, you would discover there were 30. The next question says choose a variable for D. Well, choose a variable. In this case, we're going to select D for the design and tell what it represents. Then use the variable to write an expression for the number of red tiles. So what we're going to say here is that if D is the design number, what is the relationship for the number of red tiles? Well, if they're all going up by 2s, technically, are we not multiplying by the design number by 2 to get to the number of red tiles? And so we would say that D, the design number, times 2 is equal to the red tiles. Now, math teachers and mathematicians, math gods, this is ugly. We don't like this. We don't want to actually use the multiplication symbol. And the reason why is because, as you discovered in a previous video, is that we don't want this to accidentally get confused as another variable. So the better way to write this would be as a numerical coefficient with the letter or variable right beside it. And so that would equal, again, the number of red tiles. Now the next question says, well, choose the same variable, well, in this case D for design, and then we'll use it to write an expression for the number of white tiles. Well, same thing like we did for the red tiles. We're just looking at what is it increasing by? What is the pattern? If we go back to our table of values, we'll notice that it seems like the white tiles are going up by groups of 10. So again, we might say that we'll let D represent the design number. And what's happening? Well, it's going up by 10. And so we will discover that 10 times the design number is going to equal the number of white tiles. And again, we wrote it like mathematicians and the math gods like. We don't want another variable in there, so we know that this is the numerical coefficient, and this is the variable, and that means to multiply. Question D then says, what is the relationship between the number of red tiles and the number of white tiles? Let's look at the numerical coefficients. Well, as there are 2 red tiles, that means that there are 10 white tiles. When there were 4 red tiles, there were 20 white tiles. 6 red tiles, there were 30. So what is the relationship? How did we get from this number to this number? And if you take a look, there should be a pattern that you might see. So the pattern that you hopefully see is that to get from the number of red tiles to the white tiles, there was a consistent increase of about 5 times. Okay? It was multiplied by 5. I'll just say multiplied by 5. So we can assume then, if we know the number of red tiles, it'd be very easy to figure out how many red tiles there were. It's just that we're going to multiply it by 5. Okay, so if there were 16 red tiles, we multiply that by 5, we should get the number of white tiles in that part of the design. Now, if you multiplied 16 by 5 and you got the answer of 80, you'd be correct. So in that design, if there were 16 red tiles, we know that as the red tiles were increasing, they were increasing the white tiles by a factor of 5. So 16 red tiles times 5 would give 80 white tiles. Why don't you try and go on to the try example? You'll see a white and blue triangle and a question that's very similar. Give that a try.